Alright, this is an assembly of a shock absorber. Okay, now we are going to study how the cylinder of the shock absorber is designed. So to do this, okay, I open this part. Alright, so we are only particular on the cylinder, so I have to do it suppress until this area. So we are only particular in how this is designed. Alright, so we go on the first sketch how it is designed. Okay, so he used a revolve both space on this design, so the sketch is like this. So normal 2. Alright, so this is the sketch with the dimension. Okay, he make a center line. Okay, and then he drew a rectangle and put a fillet of radius of 1 mm. Okay, the height of the rectangle is 35 mm, so he never put a dimension on this side, so we can go sketch and see the dimension. Okay, we can just put dimension, so it's a 29.37, so we don't need to change this dimension. All right, so 39.37, and then straight line going down, so with a thickness of the between the toe line of 5 millimeter, and then the height of the toe line we got here until to this point is 180 mm. Okay, and then we got an arc connecting the two there, so the distance of this toe point is 5 mm, so meaning he just make one square and then he make an arc, and then we have again here the distance of this line is 3 mm. Then of course the remaining line never put, we can put, and then this is 4.5 mm, so we don't need to change, so it's a 4.5 mm. Right, so he make a center line, and then after that he revolve. So this is the sketch. We close the sketch, and then we edit the revolve. So we use the line, the center line on the axis of revolution, and then of course the sketch. All right, so 360 and then check. So after that he make a helix. Okay, so the sketch of the helix, we got this sketch 9, edit. All right, so sketch there, meaning on the original plane, which is this should be on the right. No, it's on the top plane. All right, it's very far from the top plane. Okay, so on this base, so in short he used this base. To know that, we can just right click on the helix, we close, we right click, we close the sketch, we right click, and this is the plane. Okay, so he used the base, he sketched on the base to sketch the circle. All right, check. So the dimension of the circle, okay, I think he only convert entity. So if we go here on the sketch, edit sketch, all right, there is no dimension, so meaning he used this edge. Okay, he just convert entity on this area. All right, so after that, then of course inputting a helix, if you are here on the sketch, then you must be on the features, and of course on this curve it should be here. Okay, so close, so he put the helix, we edit the helix. So the helix, we got a pitch of 5 mm, meaning the distance of the thread, so we got 25 revolution, and then he put only 135 Why never put 136? Okay, I think there is no difference even we put 136. Okay, or even we put it 360. Or the start of the angle, he used 135. Okay, never mind, we just changed to 135 clockwise direction and then check. So this is the length of the threaded area. So after that, of course, you cut the sweep. Okay, and then on the sweep, the sketch will be of the thread is this one, normal 2. Let's see what is the dimension. Okay, so the tip of the thread is 1 mm. All right, the height of the thread is 5 mm, and then this side is also 5 mm. Okay, so 5 mm for this side, the tip is 5 mm. Okay, then of course it is drawn on a symmetrical way, so therefore it is use a mirror. So it sketch only this area and then you mirror this area. So done. Okay, and then we close the sketch. So this is now the thread. So after that, he used a cut revolve. So we see where is that cut revolve, edit sketch. So he edit on both sides. So he cut this area and he cut this area. Of course, in order for you to make a revolve, you have to draw a center line on the middle and draw two rectangular. It depends on what the type of cut you're going to make. So he make this cut, so that's why it's look like this. But this one, if you want to make this one better, you can make this not horizontal, but it's a bit inclined. Okay, but anyway, this is how they do. So we close. All right, so that's it in how the cylinder of the shock absorber is made.